A bottling company uses a filling machine to fill plastic bottles with cola. The bottles are supposed to contain 300 milliliters. In fact, the contents vary according to a normal distribution with mean of 298 and standard deviation of 3. Okay, so we know that X is equal to the amount of cola in a bottle, right? And we know it follows a normal distribution, so X is normal with mean of 298 and standard deviation of 3. Okay, so part A, what is the probability that an individual bottle contains less than 295? Okay, so since we know X is normal, we can standardize this. So Z less than 295 minus the mean over 3, right? Okay, so this is equal to the probability that Z is less than -1, right? So let's go to our table. Okay, so here's our table. So -1. So -1 is here. And then 0 here. So it'll be this last column here, right? So it's 0.1587. So it equals 0.1587. So if you were to take a random bottle from this factory and its contents were to be less than 295 milliliters, the probability of that occurring would be about 15.8%, right? Okay, so part B, because we have another part, right? Part B is asking, what is the probability that the mean contents of 6 randomly selected bottles is less than 295 milliliters? Okay, so we have our N, the number in the sample is 6, and we're trying to find the mean of these 6 bottles, and we're trying to discover what the probability of the mean of those 6 bottles being less than 295. Okay, so we know if X follows a normal distribution, right? So it was 298 and 3, then X bar follows a normal with the mu of X bar is the same as mu of X. And, well, actually, I'll just put this for in general. So mu of X and then standard deviation of X, right? And then X bar would be, is normal with mean of X. They're the same mean. And the standard deviation would be the standard deviation of X over the square root of N. Okay? So if X is normal, then X bar is going to be normal with the mean of X being the same. And the standard deviation, use the standard deviation in the X one in order to calculate this one. Okay? So let's go ahead and figure this out. So mu of X bar is equal to mu of X, and we figured that as 298, right? But for the standard deviation, in order to calculate that, we have to get the 10% condition to meet. Okay, so remember the 10% condition is N has to be less than or equal to 1/10 of big N, where big N is the number of bottles at the bottling company. All right, so we can pretty much see that this is going to work. We know N is 6 is less than 1/10 of N. And then if we were to multiply both sides by 10, this would be 60 is less than or equal to N. And I think it's safe to say that there are more than 60 bottles at the bottling company, right? So this works. So we know that the standard deviation of x bar is equal to the standard deviation of x over the square root of n. The standard deviation of x was 3, and this was the square root of 6, and this is approximately 1.2247. So now we have that this implies that x bar follows a normal distribution with a mean of, what was the mean again? The mean was 298, right? Yeah, 298. And standard deviation of 1.2247. Okay, so now we're trying to find the probability that if we were to take the average of these 6 bottles from this company, that their average is less than 295, right? So since x bar is normal, that's the probability that z is less than 295 minus 298 over 1.2247. And this is equal to the probability that z is less than negative 2.45. And if we were to plug that into, well, look it up in the table, right? So let's go ahead and do this, erase this. So the table, negative 2.4, and then 5 over here. All right, so we can see it's 0.0071. So is equal to 0.0071. So the probability of the average of those 6 bottles being less than 295, right? 295 milliliters is 0.0071, so about 0.71%, right? So really low. So the chances of you getting 6 bottles from that company, right, randomly, and taking the average and then that average being less than 295 is a really low chance.